Alright, so today we'll be solving 5 problems in their exponential expressions and equations. Alright, so the first that we're going to be solving is simplifying a single radical expression. Alright, so let's get started. Alright, so today our problem for our first one is 4 inside radicand to the power of 80 to the power of 4, which 80 is inside a radicand. So what you're going to start by doing is factoring out 80, okay? Because 80 is not a perfect square. Alright, so we're going to start by 40. I like to go by 2s because it's the easiest thing to do. So 40 and 2. And 42 stays the same. Then you have 20 and 2. Factor out 20. 10 and 2. Factor out 10 to 5 and 2. Okay, and that's all you can go. So you have 4 2s. That's where your 4 comes from. And then you have your 5 right here. And your 5 will go under your radicand. So you're going to pull out all your 2's, okay, since they're all square numbers and they're supposed to be on the outside of the radicand. So your new equation is going to look like this. And since 5 is not a perfect square, it's going to go inside. It's going to stay inside the radicand. Then you're going to have 2 to the power of 4 right there. And that would be the new answer. Alright, so that would be simplifying a single radical expression. Our second problem that we'll be solving is multiplying 2 or more radical expressions. Alright, so today we have, let's see, 5 inside the radicand to the power of 6 times 3 inside the radicand to the power of 6. So let's do, I want to do green this time. Alright. So since they have the same exponents, nothing will change. The exponent will stay the same. So we're going to go here. And so you're going to have your 6 as always. And then you're going to have 5 and 3. And all you do is times these two numbers. So multiply. And that would give you 15 inside the radicand. Now that's just doing it with exponents. If you had two different exponents, like let's say, so now it's going to be 5 times 3 again, and then you have 6 over here, and you have 4 right here. You would just add the exponents. You would add the exponent, and then, 15, and that would be your answer for that one. Okay? So then let's move on to our next one. And our next one is adding or subtracting 2 or more radical expressions. Okay. So today we have 32 inside the radicand and 5 on the outside, minus 7 inside the radicand, 8. Alright, we're going to do blue this time. Alright, so what you're going to start by is factoring again. So you're going to have 4 and 8. And since 4 is a perfect square, you're going to bring that down and put that inside the radicand. 4 times 8, which is equal to 32. Then you're going to factor this out to 4, 2. Since 4 is same thing, we're going to put 4 times 2. We're going to pull out your 4, pull out your 5, and so now it's going to look 4 times 5 here, 8 inside the radicand, and then 7 times 4 outside, and then 2 inside. Then you're going to times that, so it's going to be 20 outside the radicand, 8 inside, minus 28, 2 inside the radicand. Okay? Staying with me so far? And then what we're going to do is factor out 8, since 2 is not a square, it's not a perfect square, can't be squared, I'm sorry. It's going to stay inside the radicand. Okay? And we're going to divide 28 by 2. So we're going to go ahead and bring this side down. So 14, I'm sorry, negative 14, radicand 2, okay? So we're going to factor this out to be 4 and 2, and then I'm going to bring that down, 4 times 2, 20 over here, then we're going to take out your 4, I'm sorry, I messed that up. Okay, hang on. Since 8 has a perfect square in it, you're going to take this out, okay? You're going to add it to 20. So it'd pretty much be 28, the same thing as 4 times 2. You can factor out if you want, but either way you're going to be taking that out. And then you're going to have 2 back and side, because 4 and 2 factor out, but you got to times it. So that goes outside. So you're going to divide, and so now all you're going to do is minus. Oh my goodness, I'm so sorry. I had it right the first time. Dang it. I'm sorry. 4, I'm confusing myself. 4 and 2, and then you're going to put your 4 times 2 on the inside of the radicand. You're going to have 20 out here. You're going to pull out your 4 since it's a square number. Then you're going to add 24 because it's 20 plus 4. Inside the radicand is 2, minus 14, and then 2 over here. And all you're going to do is take 14 from 24, which would be 10 radicand 2. And that would be your final answer. There we go. Alright, let's go on to the 4th problem. Oops, should keep that open. So our 4th problem is changing a radical expression to 1 using fractional exponents. So pretty much what that means is only have an x by itself, like that, just by itself, okay? So all you're going to do is this number is always going to be your denominator, okay, when you do this, okay? And this number is going to always be the numerator, okay? So let's start this. And what's first thing that you're going to do is put parentheses around this, like that, okay? And then you're going to have, this is going to be a fraction, right? So this would be x inside the radicand to 2 over 7, like that. I'm sorry, I got that mixed up. Reboot. Okay, what you're going to do is, this is always going to be your numerator. This is always going to be your denominator. So, ND. Numerator, denominator. So it's going to be 7 over 2. And then you're going to put this inside parentheses, right? Same as always, bring any parentheses. And you're going to do 2 over 7 now, okay? And this mark out, right? So that pretty much leaves you with just x, and that'd be the answer. Now, if you have an equation that is just, let's just say 3, this number, you have no denominator, well, 3x, and they want x by itself, then you have no denominator and no numerator, then this is always going to be 1, and this is always going to be 2. Okay, so say if you had that equation, you would have your parentheses, you have 1/2, and you have 2 over 1, that marks out, then all you do is divide by 3 and you'll have x by yourself, okay? And now, the same thing for this equation. If we have, let's say, 3 power of 9 and you have nothing over here, this is always going to be 2. So you're going to put your parentheses, going to put 9 over 2, and then you're going to put 2 over 9, marks out, and then you're going to divide by 3, and you'll have x by yourself. I'm sorry for my x. Alright, last problem. Woo! Alright. Our last problem is solving an equation that involves exponential expressions. Okay? So let's solve this with a green marker. So what we're going to start doing is, since they have the same base for the exponents, the same base, which would be 10 and 10, we're going to do the exponents. So it's going to be 1 minus x equals 4. This is your exponents, remember all that. And then what you want to do is switch the 4 and the x so you know it's equal to x. And then so what it's going to be is, it's going to be plus x, that marks out, you add it over here, and then minus 4. Then it's going to be 1 minus 4 equals x, like that, okay? And now all you're going to do is solve this, which would be -3 equals x. And then so your final answer would be 10, 1 minus And then this would be your answer for your x, and then all you would do is plug it in, which would be 10, 1 minus negative 3 is equal to 10 times 4, and 10, sorry, I'm drawing a blank. 10 times 10 times 10 times 10, that'd be 100 times 100, that'd be 1, 2, 3, 4, so that'd be 10,000 equal to, hope this is right. Yep, that would be right, because we just would change the positive. This would be 10 to 4, and it would be 10,000 too. All right, and then so first you would have to solve for your x, and then all you do is plug it in after. And that is how you solve a couple exponential expressions and equations.